the first day of the conference? Well, we're still here. So welcome back. We like to start as a one big community, and then we fan into 3 different aspects of software engineering, and then we reconvene here, and then we have a happy hour, and at this time we also have a fireside chat. So this is personally really exciting to me. So last year, who was here last year? So last year I kind of moderated all the panels because I like doing it. But I kind of realized that I kind of reached the level of my competency. And so I'm only moderating one panel today, which is still beyond the level of my competency, but I love history of software engineering, and I think we have really, 5 years is a huge, it's half life of like dog life. It's really a tremendous epoch in. It's a really long time, right? What I'm trying to explain. If you've been in this industry, right, 5 years ago, a lot of things which we take for granted are ubiquitous. And I think, personally, that a lot of credit goes to this community and it goes to Twitter, right? And a lot of folks who basically started this, they fan out into the world. So once we're at Twitter, and I actually tried to do similar things last year, but we kind of didn't get the momentum. And I think this year we succeeded in bringing some of the original folks who started the technologies in use everywhere. They started them at Twitter. So their kind of goal is to kind of do a recap and understand how these technologies fit with each other, what each of them does, right, and what is kind of the contribution to global community, where people can take them, where people can make use of this tech. So it's supposed to be a conversation. First of all, not everybody has a mic, so this is going to be teamwork, right? So this is for the panelists. Basically, we're going to do like a distributed system where you look for the nearest mic, and we'll see how this goes, right? So we'll have a little distributed system going on here. We need consensus. And this is supposed to be a conversation. So I'll ask you guys to introduce yourselves and describe kind of your original story, compressed at Twitter, and how it led to the things you are doing now, right? And hopefully we'll pick up on this. And maybe one thing I'd like to see if you can think about is how do you relate to other people in the stack? So consider this a kind of stack, right? Maybe out of order. So Ben should be somewhere like platform-wise under everybody, right? But we're like we're horizontal. So if you can kind of think, give us some hints how you relate to other people in the stack, and maybe tell us how historically how you were relating to each other when you were overlapping at Twitter itself. Maybe we'll start from Marius.
All right. So you're saying this is the yapping philosopher problem?
Exactly.
Yeah. It's avoided deadlock. Anyway. So I'm Marius Eriksson. I was at Twitter from 2009 or so, late 2009 until last year. I'm now out of the online transactional processing business, and I'm working very happy working on batch computing, processing very large data sets. At Twitter, I spent some time doing the sort of initial geolocation stack, and then as we transitioned into a more service-oriented architecture, I helped start the project that became Finagle, and a bunch of other kind of downstream projects from that. So this includes something we call Wiley, which is this naming system, and a few other assorted projects that relate to that. My last year at Twitter, I worked on something that's really, really exciting. I think also kind of an evolution of this space, but I'm not sure I can actually talk about it here. So that's my TLDR.
Hi, I'm William Morgan. I work at a pretty cool company called Buoyant. And let's see, I was at Twitter 2010, I think, to 2014 or so. In contrast to the many illustrious figures on this panel, I was mostly a parasite that didn't really produce very much of value. And that's it. Yeah, no. So I was there as an engineer, mostly primarily as a service owner. So I built some of the early kind of media services, and now what we do at Buoyant is much more related to stuff that I didn't actually kind of directly touch. That I was a happy customer of things like Finagle. But my co-founder Oliver, who's not here, is the one who actually knows how to program computers these days. So I'm mostly here to paint the rosy vision of how awesome everything is.
Hey, my name is Evan Weaver. I'm at FaunaDB right now. I'm CEO and co-founder. It's a distributed database company available in the serverless cloud on premises as well. And that's a direct descendant of the work we did at Twitter on what was called the infrastructure team. Because I joined Twitter in May 2008 as employee number 15 at the time. There were about 6 engineers. Alex Payne brought me on, who probably has something to do with many of your introductions to Scala. And I ended up managing the engineering team that built all the distributed storage for the core business objects. So that was tweets, timelines, the social graph, user storage, image storage, the cache, probably some other storage. There's a lot of storage. We didn't do ads. We didn't do analytics. We didn't do anything that was outside of the critical customer-facing request paths. But basically, our story there, and I'm not sure, probably to their benefit, I'm not sure I directly managed anyone else who's sitting up here. But as the team grew and we expanded into a service-oriented architecture and eventually a microservices architecture, my team was frustrated that we had never had the chance to build a truly reusable storage platform, especially for transactional data. So essentially, Fauna is that platform.
Is it still on? Yes. It's still on. My name is Mark McBride. I joined Twitter in 2009, little before Marius, but not much, and stayed through 2012. My first job there was working on the streaming API, which I think was Twitter's first production Scala service. So that was an interesting road. Managed that for a while, and then managed Twitter's front-end traffic management team, which resulted in TFE for a while during one of its darker periods. And then went from there to looking, as Twitter got more service-oriented, trying to improve productivity across the team as we got more services, more changes to the code base, and started a team called Developer Productivity, which fixed things about 2 years after I left. And so I went from there to Nest and ran server-side engineering and really missed a lot of the things we'd built out at Twitter. And so after leaving Nest, started a company called Turbine Labs, which is really trying to take a lot of the more modern network traffic management things that are available today and use them as a way to improve overall team productivity as you scale up orgs and scale up the number of services and try and get more cloud native, I guess is the term, around stuff. So, yeah.
All right. So my name is Ben Heineman. I joined Twitter early 2010. I was first a consultant, then I was an intern, then I was a consultant again, then eventually an employee. I worked at first under the chief scientist. We had a research project, which was to try to do cluster management, resource management. Around the same time, Twitter started to become a SOA, eventually microservices. And we built out a project here called Apache Mesos at Twitter, which we use to run a lot of those services. And then I started a company called Mesosphere.
Hey, I have not worked at Twitter, but they're recruiting half me. I probably shouldn't say this, but I work at Apple, and I probably can't say very much. But anyway, when I was at VMware, I started, jumped into Scala and Akka at the same time on it was the first Scala team at VMware a while back. And we were working on, it was 4 senior engineers doing a new cloud orchestration service for companies like Verizon. And from there, I went into, I actually was an early contributor to Akka and Akka Cluster when it was still experimental, adding 2 new features. After that, I joined a CrowdStrike, which is a cybersecurity company, and that's actually where I got into analytics. And I realized after I built, a couple of pipelines for them, the first ones that they had in Scala, and I realized that, Hadoop really sucks. And this whole batch thing also is kind of lame. We need to do some real-time detection. And so I started to look into what those architectures could be. And this is when all of the way that we do things now, no one was really doing them. They weren't really live in any systems, I think. And so I found some folks at DataStax that were also interested in, doing away with using Hadoop and doing things more in a streaming manner. And so I joined them and started working on systems like that, and with Kafka, and just making everything much more real time. And now I'm at Apple.
Thank you. I guess one question I have about software stacks. Right? So we talk about real life software architectures. So one way people talk about stacks, right? And let's question everything. So do we need stacks, and what stacks should look like, right? So I think it's very interesting for me to see that. So Helena opened this morning about distributed systems, which are built. A lot of them are built as stacks. So we talk about the SMAC stack, right, which is Spark, Mesa, Saka, Cassandra, and Kafka, which basically a lot of companies keep reinventing, right? So if you look at any large web-scale company, they have an API, maybe it's user-oriented, so they have millions of users banging on iPhones, right? Then they have an API. Then they have a message bus, they have compute, they have persistence, they have operations, right? So that's essentially SMAC stack. So every letter is replaceable, and every letter does one thing and does it well, right? But now we see a very interesting thing. So each of you guys from Twitter kind of took their letter and went away with this, right? And maybe, and so you kind of want to provide that piece of the stack as a service, so you expect others to integrate with that. And so what's interesting to me, for instance, Fauna is doing stuff in the database, right? So like everything can be done in the database. Streaming people say everything can be done in a stream, right? Like you just stream stuff through it, and Kafka added Kafka SQL, KSQL, right? So it's kind of every letter says, I'm the main letter, right? It's very easy to add stuff to me, and I will do everything for you. And so I'm curious, can it all be true at the same time? And that's one thing. So what is your kind of vision for your letter, as if to say that, so you like people at Twitter were in the same company, right? So it's easy to communicate with a common code base, right? There is a lot of boundaries are not there, right? But now you kind of when you separate these concerns, you basically become the service-oriented global marketplace of services, right? And so there is a whole bunch of problems now, because when customers come in, you need to onboard them and to tell them how to interact with your system. So I'm basically curious, what do you think about this idea of a stack, right? And how can it be viable for individual letters, right? And for Helena, I guess, kind of who implemented the SMAC stack in open source, right? Maybe like, what is your view, basically, right, from the outside of the letters on this?
So I might want to shatter that idea. What I've seen is, I used to, in smaller companies, see that as applicable, but now I really, and in recent years in general, actually, I mean, there are so many different use cases. There are so many different sizes of projects between where a system needs to, the variety of places projects need to store data, and how they need to store it, and how often they need to access it, and what's accessing it, what algorithms you're using to access it based on where it's stored globally. I mean, I think that it's not that simple at all, which I think is no surprise to anyone in the room. I mean, I think the SMAC stack is very applicable to many situations, but there's so many cases at the same time where you have to interject other technologies as well. And the thing that I always like to talk about is the collaborative type of technologies, where you might have that foundation, but there's other ones that work in collaboration with them too, to add on.
So I'll throw in, I mean, from a, does a stack make sense perspective, or what's important about a stack? I mean, I think the most important thing is if the technologies can compose well together. So I agree that, I think SMAC is sort of, to me, it's a good initial perspective, but there's other C's and K's and Q's and R's and T's and V's and whatever else that most organizations, I think, ultimately will probably adopt. And I think what's just critical is if we can think about just building the software in ways in which it can compose well together, so you can bring in new services to help solve certain problems easier and replace services. And that's sort of what's going on over there. They're not composing well. Yeah, so to me, that's I think the most important part, less exactly what the acronym is, more that the technologies can compose.
So I would take that even further. I would say that, of the kinds of interesting engineering products that exist, they usually either tear those abstractions down or erect new ones, right? And so I can give some examples. So we sort of build up this set of assumptions about, or the shape of the way you solve particular kinds of problems, like this SMAC thing or Hadoop or whatever else. And then somebody comes along and says, actually, you know what? This would be much more elegantly solved if it's done directly in some way. Or we actually introduce a new kind of abstraction, like Oscar likes to put monoids everywhere, right? I feel like those two things, so this sort of like an interesting balance to strike. I can give a recent example from my own experience. We have a data processing system at where I'm working now, which I talked about this morning, where we were actually able to, by basically not reusing the kinds of traditional systems that you might think, like Kubernetes, for example, we're able to just dramatically simplify an entire software stack by building effectively a monolith. And it ended up being far easier to reason about the whole thing, to introduce new features, to introduce tight coupling, because that's actually what the problem needed, right? And so I feel like ultimately the only the real answer is that you always need to solve problems and not think too much about stacks, right? If it happens that your letters are useful tools to use, then by all means use them, but don't lose sight of the problem that you're solving, right?
Did you call Kubernetes the traditional stack? So we had an interesting experience with Linkerd, which is our open source project that I think is kind of blew me away. Where we started basically with Finagle and we wrapped this thing up as a proxy, and we're like, all right, this thing is going to be really useful, to people who are like running microservices. And okay, so what are we going to call it? Well, it's an RPC proxy. So like we called it an RPC proxy, and people were like, well, I don't need that. And first of all, I've got HA proxy, and we're like, no, it's totally different from HA proxy. And then they're like, and we're not even using RPC, like we're using HTTP. And we were like, no, in our ontology, see, HTTP is like a subset of RPC, so it totally makes sense. And by the time you went through that conversation, they were like off doing something else. And so we had to iterate on what we were calling this thing. And like eventually, after calling it like an application router and RPC proxy, we started calling it a service mesh. And that was like a new term that we invented, and like no one knew what a service mesh was. I mean, we didn't even know what a service mesh was, but by giving it this new name, it was like a blank space where we could write in there and we could say, hey, and this is what a service mesh is. It's a dedicated layer for infrastructure, for managing your service-to-service communication. And so now, like when, the idea kind of caught on, and like the service mesh is now part of the cloud native stack, but that was not a thing that happened. That was not a thing that existed, or that was not part of the stack, even a year ago. And the product hasn't changed, right? Linkerd hasn't changed. Finagle hasn't changed. Like this thing is still the same thing, but the way that people are thinking about it, the way that people are understanding, like what you have to compose together has changed. So I guess what I'm trying to say is like the notion of a stack, I think can be useful. Clearly, it's a guideline, but it also changes over time in not just like adding and removing, but also like inserting things and repartitioning and moving functionality around between the border.
So should we call it SMACs or SMAC?
Twitter, as I'm sure you're well aware, started on Rails, which was an iteration of the LAMP stack, and to an extreme degree too. And I think the way I view it, like a framework or a stack is a stepping stone. It helps you get something up and running end to end very quickly, but obviously Twitter did not end on the Rails stack. And I don't think any modern consumer, enterprise, web property, whatever you want to call it, has actually conformed to the guidelines laid down by whatever framework they started with in the long run. And I think, similar to everyone else, what we've discovered is there's a huge diversity of potential problems and potential tools out there that people want to use with your own software. And our goal with Fauna, for example, is basically to make the biggest possible hammer for a set of common problems and let you do whatever you need to do to solve your specific problem. And the concept of a stack doesn't really come into that because we want to play nice with whatever other systems you need to use.
Yeah, and I think from our perspective, like Stack is interesting as frameworks, but I think a lot of the things that have happened recently in compute over the last 2 or 3 years have really made it much easier to deploy a much larger number of services than people were a decade ago. So you have companies like Uber that have, I think, more than a service per engineer at last count, which it still seems nutty. But a decade ago, that wasn't the case. And now that you can do things like move to containers so you can deploy things at a granularity that's less than a single computer easily, you get smaller processes that are worthwhile to run. At Twitter in 2010, you felt bad if you weren't consuming all the resources of some type on a box. Like it wasn't worth it to get a machine to run a process that was going to use 64 megs of RAM. It just didn't make sense. But with containers now, sure, you run 50 of those containers on a box and it makes sense. But as that happens, I think the challenge becomes more in what's the organizational infrastructure you need to help teams work together in that environment. And so you run into cases where there's lots of different stacks in use, but teams still need to work together to get a consistent experience out to customers. And looking at the tools you need to make that happen is, equally interesting to us as it is what particular letters you're using in stacks across the company. There's very few places, I think, over time that keep a single consistent one. Google's probably the exception, but I think even Twitter was we're just going to be Mesos in our own data centers. And then you acquire Vine. And it's okay, well, you can stop doing development for a year and a half and move into Mesos in our data centers, or maybe you get to keep running in AWS and we can ship features. And so I think that kind of embracing organizations that use different stuff but having common abstractions that let you ship an experience out to customers is a different sort of abstraction layer that you want to work across and get standards defined in.
I will say that probably one of the most valuable parts of the acronym is to just help classify a set of problems that people are thinking about solving. I mean, we heard the word LAMP earlier, which, most organizations that I went and chat with, they were not exactly LAMP, but they were taking this patterns of LAMP to try to solve their problems. And I think that's a really, really valuable part of these acronyms and these stacks. When we think about them, they're just going to have lots of different letters. But it helps us all collectively oh yeah, okay, I want to solve this class of problems, and people are solving it with LAMP, or people are solving it with SMAC, and that can be really helpful from that perspective.
It's interesting in the LAMP case, the only part you actually provided yourself was the P. Everything else was, just like a template, right? And sort of out-of-the-box software. And so you only iterated on the P ever.
Well, we iterated on the M,
yes.
too.
Yes. But most people ever only iterated on the P, right?
And there are lots of people that were also not doing it on the L.
Right.
They were doing it on something else. Sometimes a W, sometimes a
But anyway,
S.
I guess my point is that that seemed like a simpler time, right? There was sort of a
It was a simpler time.
There
Less
was
users, less machines.
I know, it was awesome.
Less
Let's
functionality,
go
less
back.
everything.
But there was just sort of this one variable that you kept changing. But now with this sort of modern computing environment, you're changing everything all the time. And like SOA, for example, is more like an archetype than it is sort of a kind of pattern. And you're left to answer lots of questions on your own. With LAMP, there was really not that much. There was not that much variability between different implementations, right? And so I think that's something to keep in mind actually as you move forward. Like what, the beauty of something like LAMP is that it was very simple and easy being a developer, and really, really simple to iterate and push new things out. As we've added all this complexity, sometimes for good reasons, sometimes not, we often make it much more difficult to actually operate and to deploy and practice and so on and so forth. And I think that's kind of a sort of underappreciated aspect of engineering generally, the sort of developer productivity aspect of this as well. And I think, it's just something to keep in mind, I guess.
You made a really good point about, it made me think about how there's literally no technology that solve a problem that you can apply to every use case. And so in the framework of a stack, I don't really see that as a way to see things, because in every project, every company, you might want a few base things like Kafka, for example, or Cassandra or something, Mesos, but there's all these edge cases where you need to apply other technologies with them. And so.
Thank you. So I hear patterns, right? I hear that a lot, and so I'm curious. Can you think about for you, those of you who have companies who serve external customers, you see these patterns in the real world. So what do you see? Can you generalize in terms of architecture? What do you see? What is it? Traditional architectures, customers, what do they actually have, right? Like we hypothesize they want them to be all advanced like Twitter, but a lot of them are not. So what do you see in the real world, and where, for those of you who provide the letter, where do you provide the most service to those customers, where you plug in them, right? And for folks on the edges who not have companies, but in a huge company or kind of in a startup, right? How do you there are probably some patterns there as well, right? So what kind of patterns do you see emerging, and where do you want these patterns to go, if somewhere?
All right, I'll start. So I mean, one of the big truths for a lot of organizations that are outside of the Twitter tech companies is that there's a lot of work to get those organizations to actually change the way that they do things to work with a lot of these modern technologies. A lot of the technologies were built assuming particular expectations about the environments in which they can run, like places like Twitter, and it's a big jump. So I mean the obvious big patterns that we see a ton is people moving to microservices, which we didn't call it microservices at first. Ravi had SOA on all his slides when he first talked about it. It was just without the message bus for the most part. And then eventually the term microservices came on. But a lot of organizations trying to adopt that pattern, they really struggle. And some organizations it actually doesn't make sense. Like perhaps Marius's organization sounds like it didn't make sense. And that's totally fine. The other big pattern that we do see though is people basically want to. We see the SMAC pattern a lot. Sound like a broken record up here, but we see basically people want to get some data in, do some processing on it, store it for long term, serve out some information from it to other people, and they want to be able to do that. Really elastically. When there's more data, they want to be able to run more computation, and when there's less data, they want to run less. That's a pretty typical pattern, but again, a lot of the letters tend to be swapped in and out. Those are probably the biggest patterns that I see at most of the organizations we talk to. But the one thing that I think is interesting is just that a lot of organizations that are outside of traditional tech companies. How many people have heard of the term digital transformation? Okay. So who hasn't heard of digital transformation? Raise your hand. Okay, that's. I appreciate the honesty, right? So digital transformation was a term from like a decade ago, and it's still a term today because big companies are actually trying to digitally transform themselves. Because it's really hard because companies still run mainframes. Who runs a mainframe? Anyone run a mainframe here? All right, we got one. Right? A lot of the organizations we chat with, that's what they have. They have these mainframes. They have a lot of really old tech, and so the pattern to move to microservices is a tremendously difficult pattern. They need a lot of help with the tech, and what Marius was talking about earlier, I think is a really interesting point. Somebody asked me the other day what I thought was the scariest thing for these big enterprises looking to do something like SMAC, and my answer was that there's a new acronym, there's a new letter for the acronym like every week. So it's just like it's no way you can catch up to that. Like you gotta. So again, it gets back to what I said earlier, which is the best thing is to find some technologies that compose really well together, solve your problem with those technologies, and then move forward. You're probably going to replace some of those technologies in a couple of years. That's fine, but you should pick some good technologies now that can actually solve the problems. You're still not very good composition over there between those two.
I was just going to say, we talked to a lot of companies at Buoyant because of the nature of where Linkerd sits is like, kind of deep in the horrible like bowels of like their systems. And the one kind of constant that we found is that any company that's been successful, it just has a mess inside. It's just like it's never clean. It's never pure. Like, the only clean, pure companies are the ones that like die. If you, like life is shit, guys. Like that's really what it comes down to. No, the reality is like if you survive, like you do it by kind of scrambling from thing to thing, and like you end up with these horrible systems, and everyone feels really bad. Like when we talk to them, everyone's like, "Yeah, I'm really sorry." Like we kind of got halfway through that thing, and then we had to shift over here, and then this other thing. So everyone's really apologetic about their own mess, but everyone has this mess, and I think. I don't know if there's a lesson to be learned from that other than like, if you are like, I think you just have to expect that you're going to change. Like Ben said, you're going to change your infrastructure layer. You're going to change a lot of your dependencies and assumptions over time. And like, it's going to be very, very rare for you to have something, that actually lasts for a really long time, unless it's super, super hard to remove that. And even if something is old, you usually kind of surround it in layers of other stuff. So, yeah, I think that's what we found. It's like, it's horrible out there.
You can speak for yourself, William. I think
one of the storage layer, which is beautiful.
To that point, one of the interesting things we've noticed is that there's a lot of customers, especially the bigger the enterprise and the more risk there is to change, who will just skip multiple generations of what we would consider technology progress, because they're waiting for a new wave which is compelling enough to actually be worth the investment. And like this happened to an extreme and very obvious degree with the first generation of NoSQL, for example, where a lot of companies got badly burned by inadequate implementations for new data systems in particular, fled back to their legacy Oracle clones, and are staying there waiting for something which can actually improve on every dimension of their experience of using those systems, rather than be a strict trade-off between usually upfront productivity on one side and then operability, data integrity, correctness on the other. And I think another example of this is cloud operations generally, which is what's driving first the containerization movement and then also the serverless movement, where people were like, oh, the cloud's super awesome. Wait, why am I still using CF Engine to like mess with my EC2? This solved nothing. It's just a different way to buy hardware, but it's equally difficult to develop the software. And those adopters said, well, okay, we'll move some workloads to cloud. Maybe we'll do some new stuff there, but we're not going to try to constantly forward port everything to the next trend. And I think, I don't know if this is part of like digital transformation generally, but I think in particular the enterprise has gotten a lot wiser and situational about when to adopt new technology, which ultimately is good for vendors because you have to actually deliver high quality software. You're not just chasing trends and trying to sell fads. Like the early days of SOA when XML was supposed to solve all your problems, and if it didn't, you used XSLT, and that solved all your XML problems. People made a lot of money on the conference circuit for that, but they weren't helping customers deliver business value. And we sort of saw that again with the first generation of NoSQL. I'll let the container people. We don't use containers. We use Java. Write once, run anywhere. Run anywhere. The dream of the '90s is alive at Fauna. But the container people can talk about how, you know, the early days of like Docker in particular, some of these other configuration platforms, maybe if you consider Puppet and Chef forerunners of that, didn't really pan out in terms of business value. And I think the thing that is most gratifying is that customers know it and are making much wiser engineering decisions, not just, we'll use the trendy stack.
I would say as another way of, almost another way of phrasing what Evan just said is that, you know, I think ultimately a stack becomes successful when it becomes basically invisible and when it becomes boring, right? Like it just does its job and it doesn't get in your way and it allows you to, you know, it's just another tool for you to solve your problem. Like nobody talks about Linux system calls unless you're a Linux kernel developer, right? They just work, they're there and they're very useful, right? And I feel like ultimately the way to measure the success of any of these technologies is to observe them become boring over time. And then I would say that that's the ultimate hallmark of success.
Yeah, another example, I think, is Hadoop. Like Hadoop has never become invisible for any, in particular, enterprise adopter. And there's a big, there's a big backlash because of that. And people are saying, you know, where's my vertically scaled columnar database? Like, let's go back to the 80s and at least, you know, build a product.
Yes, I think it is interesting to see the trends. Like containers have taken off, you know, pretty dramatically over the last few years. But the benefits containers give you aren't just that you run Docker instead of having an AMI or a VM or whatever. I think it's that you think in terms of it's not a computer, it's less than that. And that seems to be something that has accelerated pretty dramatically. Like serverless is the evolution of that. I don't even need a whole process. I just need a function. It's going to be really interesting to see where that lands. And to Evan's enterprise point, if I were an enterprise, I'd be kind of nervous about adopting Docker or Kubernetes right now because the serverless thing seems like it's right on the tails of that and may end up being the thing that wins. Like who knows? In San Francisco, like Kubernetes is definitely a thing. Mesos is a thing. There's a lot of people using that. It's really fascinating to get outside and talk to people like in Boston, where the challenges are still like, we're trying to get Jenkins set up so we have CI/CD, which is
Digital transformation.
Yeah. Yes. They're on like 4-bit digital transformation right now. But it's really interesting to see, like, once you get outside Silicon Valley, how these technologies are being adopted, and it's much, much slower. And so I think there is that chance that the pace here accelerates to a point where it's like impossible to pick what you're going to go to next. But there's always that imperative that it's never going to stay still. So one of our premises was things are always going to change. And there's a decision point of like, what's the risk for me to make this change? And what's the reward? Like, what's the payoff? How much does it cost me? Or the expected cost, and what's the expected payoff? And so we're really focused on reducing the risk in that change. And I think that's one of the really interesting things about microservices is instead of having function calls as kind of your integration point between teams, which people tried to make programmable. Anybody remember AspectJ? Anybody? Yeah, that never really panned out. But that was an attempt to make like the function call interface programmable so you could inject functionality there. It didn't really work. But with microservices now, the network has become that. And so a lot of the new proxy technologies now give you the benefit of being able to apply much more sophisticated policies at the network layer, which means you can do fancy things like gradual traffic shifting and evolution of services in a way that's much, much safer than kind of the state of the art 5-6 years ago. So if the risk is less, then you're able to move faster to make those changes and kind of keep up with all the nonsense happening now and like functionless or whatever is next after serverless.
I'll go next. I don't know if anyone's actually used the word scale yet on the panel. But as far as stacks go, one thing I've seen that's really interesting is, so I've worked at both technology and framework provider companies and users, consumers of those technologies. And when you're a provider, and I think definitely not the case with like LinkedIn creating Kafka or with Twitter, because you have a lot of data, but oftentimes the companies that are producing technologies doing a great job, but they don't have the data themselves to really thrash it. And so, you know, when you actually, like at some companies that I will not name, you might be able to say like, hey, let's try out this new technology that might be really, you know, works really well. You know, a lot of companies use it, but then you can sit there with an espresso and watch it just completely melt down under the load that you have. Even with it, you know, properly configured, properly deployed, everything like that. So I think it, you know, it becomes really interesting when you throw the scale problem at it, and that's where you have to get creative.
So, folks, I'm going to open the floor to audience questions next, right? So, our indefatigable track manager, Devin, will hand the mic. So maybe, you know, I'll ask one of you guys to surrender one of the mics. We'll have to increase our teamwork by a factor of 1/3. So, I'll ask one more question, and meanwhile, you guys can prepare. So, we'll, you know, raise your hand, and Devin will bring the mic to you. So, one question I want to ask. So we're an open source community, and you know almost everything is happening in the open source. So everybody here relies on the community, and so I'm really curious, right? How do you guys see kind of so when open source companies bring the product to the world, they need vibrant communities. So everybody is doing a lot of work in kind of cultivating the communities, given the open source, right? And obviously there is a lot of tension here, providing you know an open source version and kind of onboarding people on a commercial version. So how do you kind of you know taking stuff from Twitter out or you know I mean I don't know like Apple uses open source, not much. Kind of, you know, it puts somewhere a version of GCC, but it also has, you know, some open source. So how do you see the community, right? Like, is it still the mode of operation that you have an OSS component and have a commercial component? Is this model going to change, right? We see like a resurgence, you know, of the reaction. You know, reactions are saying like, let's just roll back open source. Let's just sell commercial software. I heard an executive at a conference saying like, you know, a pretty big company I'm not going to make, saying like, I'm going to be like, I'm going to, you know, eradicate open source. Like they're not good for security. It's a security company. We're going to not use open source because we're a security company. So we don't have a place for open source in our stack, right? So how do you see this kind of duality of open source and openness, which we, you know, espouse and see at Twitter to the extreme? You know, Finagle is a GitHub organization of its own, right? So I think it's one of the leading examples versus, you know, the tension of building commercial companies and selling software.
So I would say one sort of surprising and interesting, I guess, reason and also benefit and side effect from doing open source is that it forces you to adhere to a higher quality, right? And so one of the things, or at least early on at Twitter, one of our sort of core reasons for open sourcing stuff was that we wanted to make sure we weren't actually embarrassed by this, right, to some extent. And that's everything from the code itself to the way it's documented to, you know, the fact that you have to be able to write down a coherent sentence about what it actually is, right? And so I feel like that's sort of an underappreciated aspect of open source is that by putting yourself out in the open, you're kind of applying a higher standard to yourself. There's one, you know, it's one thing to write a piece of internal software where anybody can come to your desk with any problem they have, and you can make all sorts of excuses. It's another thing to actually put something out, and it kind of, you know, it requires, I think, a higher standard of work. And I think that was a device that we used in several Twitter projects fairly successfully, I think.
I want to totally support that statement. I think that everyone should be contributing to open source. I know that it's hard to find the time, but you become a better engineer. If you look at the code of your teammates or whatever that aren't contributing to open source, you can really tell, because people that have contributed to open source, you test things better, you document everything, it's written well, like the grammar is good, the way that you code is easily readable, and you think in terms of how you're going to construct the code so that it's easily maintainable by other people around the world. And also it's used in various use cases, not just in your company. And you have people testing it out in different deployment strategies and everything. I mean, it's so incredibly valuable. And we definitely do at Apple contribute to open source. I'm on a project where myself and Evan Chan, who presented today, were primary contributors to PhiloDB.
Yeah, so we're interesting in that we don't offer any open source as part of the company. Like we leverage open source heavily, and we commit to the projects that we use. We actually do open source one, our CLI, because that's the easiest way to get Go installed. But that's just really a quirk of Go. But I think what we've done, like to Elena's point, is that a lot of our stuff is ready to open source. We've just made the commercial decision that it doesn't make sense. And having that tooling in place and the rigor in place to say, like, if it makes sense for us tomorrow to open source this project, we make the GitHub repo public, does enforce like a lot of discipline that we would be like tempted to abandon for the sake of expediency. So I think like 90% plus of our code is like ready to open source tomorrow if we decide it makes sense. But our kind of criteria for that is like, what would be the point of open sourcing this? Would it be useful for other people standalone? If not, then why bother? If it's going to be something that's going to get us reach as a business, then that's another question. If it's purely just to say like we open source this thing, then it becomes like an API that we're kind of de facto locked into by having that project open source. If one person uses it, then we have to have like an implicit or explicit contract there. And two, it's a headache for both an adopter and us to say, like, is this thing going to be maintained going forward? So we've chosen to keep large portions internal, but go through the same discipline of it being open source ready, just purely for hygienics.
I was gonna say, so for us, we have both an open source, we have many open source projects, and we have enterprise projects as well. It's definitely there's definitely tension as in doing that. I think the strategy for us is we learn so much from people that just take the open source project and use it. That's how it worked with Mesos here at Twitter. A bunch of organizations took it and gave us amazing feedback as they put it to scale, as you were talking about earlier. It's kind of funny we had companies like Netflix, we had companies like PayPal, we had companies like other companies who would actually push it to some serious scale, and that was tremendously helpful. When you end up starting a company, like to get the same feedback yourself, the kinds of like ways of trying to run your product that way would just be prohibitively expensive to try to exercise it in that same way. That's really, really tough. On the flip side, and this is, I think, the part that is the trickiest for a lot of enterprise businesses, is there was one person in the room that raised their hand when I asked about mainframes, which to me means that 99.99% of everyone in this room probably doesn't pay for software, which means when we put open source software out there, you're going to consume it and use it, and that's great. And then what happens to the enterprise business that's potentially trying to support it? So like this to me is the conundrum that occurs. It's a very deep conundrum for an engineer who just wants to build really fun things. But I also recognize that when a lot of the businesses that are driving a lot of these open source projects, if they were to die, the open source projects would, in many circumstances, die as well. So it's a double-edged sword. It's like you definitely want to work with the open source community, get as much feedback as you can, but you also need to figure out the best way to make the business successful. And honestly, I think the jury is still out for what is the best way to monetize open source software. There's a handful of companies in the last decade that have tried to do it, and there's not a lot of companies to point to and be like, they've gone huge with a completely open source model.
One more note on open source is, we talked a bit about how working on open source makes you a better developer. But I think there's also a widespread expectation that working on open source is something people do like after hours on their own time, which is really, really a luxury for people who have after hours time to spend doing more work for free. So I'd encourage people in the room who are in a position to let people work on open source to do so. Like we do, we encourage people to do that. And if you're not in a position to do that, to start demanding that your employers let you do that on the company dime, because it's kind of, to be a good engineer, you have to get paid to do your engineering work for 60 hours a week or whatever people demand these days, plus do another 20 hours a week outside that to actually be good, is like a huge amount of bullshit for people who have, kids or other kind of constraints outside work. It's a totally unfair expectation.
So FaunaDB is not open source. And I think the business justifications for open source are threefold. It's a way to force, like others talked about, your internal team to basically ship to internal customers and not just toss lumps of code over the wall. In our market, at least, for operational databases, the quality bar is already, I think, higher than open source provides as a forcing function. At the same time, open source is a channel, which is the traditional business strategy. Either, at Twitter, we did a lot of open source, not just for quality reasons, but for recruiting purposes too. It was a channel to hire into the engineering team. For a typical open source, open core business, the open source product is a channel to sell the enterprise product. On the customer side, it's a way to increase customer choice, increase the number of ways that the product itself is delivered, the business continuity protection that the customer receives by adopting open source. At least for us, like no one wants to own their own private operational database and maintain that thing forever. So we've found that having a cloud product, in particular a serverless cloud, which is easier to get started with than open source, you don't have to provision hardware, you don't have to operate anything at all, is at least an effective channel for onboarding people into FaunaDB. Because I think the thing that's really undermined or cannibalized open source business models is cloud-operated software. Whether that's open source or not, no one really wants to operate their own software. So they'd rather pay someone to run it and operate it than operate it themselves and pay a vendor to support it.
Uh-oh. I built my entire business purely on open source. What should I do?
Should ask your
everything we do is open source, and it's a huge investment from us because not only are we making amazing code because open source is, makes us do that. Also, we're amazing people, but like we have to invest in the community, and we got to keep people excited and engaged and grow the community, and that's a huge amount of effort on our part to do that. So it's a really expensive proposition to be open source. On the other hand, it gets us into all sorts of cool places that we wouldn't be without it. So yeah, it's just a minor question of what's a cool business model on top of that, which I have a great answer for. Come see me afterwards.
Well, let's open the floor. I think Oscar was raising his hand. And by the way, Oscar is another legend of Twitter. He just, didn't
just not legendary enough. That's cool.
We don't have enough chairs.
So I kind of, I like open source. You guys were talking about it with regard to business choices, but I don't want to put you on the spot too much about this, but I think open source is important as a kind of commons for things that maybe aren't by themselves going to make great products, but they're still very important for engineering. And I think we still have a challenge to figure out how to fund and build these things. And I think Mark kind of brought up some interesting things. But just to bring it back to the Twitter angle, I would be interested to hear your take on do you think Twitter did this well or not? Because in my view, people outside of Twitter have a somewhat a monolithic view of what Twitter might have been or what how decisions got made. And I'm sure this changes over time, but people inside Twitter see it as my take, just to lay it down, is that open source is mostly driven by engineers who are passionate about it and was somewhat reluctantly usually supported by management and sometimes even met with some hostility. So I would be interested, did they get it right? Is that maybe the right take? Did, I don't know. What's your take? What should it have been?
I thought you were going to say monolithic as in repository.
That one. I'm just going to let that go.
So I felt the same way. I felt there was definitely. So I'll talk about two projects. So Mesos came in open source, which was good. There was a open source advocate at the time, Chris Anichek, who I think did a really good job actually getting Mesos to be an Apache project before it was really pulled into to Twitter. So I think there was definitely advocates that were helping, but I completely agree. I think a lot of it was pushed by engineers. So take Aurora, which was. That project took forever to open source from inside Twitter, so long that people outside Twitter started to build, many people outside Twitter built basically replacements for it. Netflix built their own replacement. Uber built their own replacements. Other companies built their own replacements, and eventually, even us, when we started a company, we ended up building our own replacement, which is, I think, horrible for the open source community because there are going to be so many. But I think there were other things that we did well. I mean, the IPA stuff that Chris pushed through, which was the individual patent agreement stuff. I think that was very, very pro open source and pro individual developer. I didn't see many companies actually doing that. I mean, I think that made engineers feel like they could work on really, really cool stuff and feel like they could actually own it. So I think we did some stuff really well. But yeah, I think there was still a lot of uphill battle.
So I think Evan talked about the 3 reasons you would open source from like a pure commercial capitalist perspective. But I think and this may be me mythologizing the generation of Twitter engineers before I got there, but Twitter was kind of rare in that they were like serious anarchists that started the company with like deeply held ethical beliefs on software in a lot of cases. And so I think a lot of that kind of bled into the later generations of engineers like me. It was just like, we should definitely open source this and make it free, just because that's the right thing to do. And so I think a lot of the open source kind of followed out of that. There may also, like, I didn't work at Google before I came to Twitter, but I know Google was notoriously hard to get stuff open sourced out of. And so I don't know if there was backlash from the people who'd left Google to come in as like, holy shit, now I can actually open source a thing without having to open source all of the Google 3 code system to do it. So I think aside from the like business justification of Twitter open sourcing things, there was definitely like, a core ethical angle of open sourcing software, and then just a freedom that this is a small enough company that we can actually get this done and it's going to be great. Facebook, for whatever reason, like about the same time, like coming up, had kind of a different experience with open source. And there's some big projects that came out of there, but it didn't seem like they were nearly, I guess, as voluminous in their contribution to open source. And I'm kind of curious, just from like a sociological perspective, why that was. But
I mean, one of the earliest reasons we contributed to open source was we just needed help. Like we were, hey, we were a very small team, especially in 2008, struggling with scalability issues, the ostensible topic of this panel, and like we got involved in the Cassandra community very early as the first adopter outside of Facebook, hosted the first meetup, fixed the build, wrote the first tutorial even before it was called Reptano at the time. Now DataStax was founded, just because we wanted a system like that to exist, and we didn't believe that we had the engineering resources to build it ourselves internally. So in that sense, like, there was a lot of idealism about, let's all, like, we're all in this together. We collaborated with Facebook on that and other projects, even though from a business side, we were sometimes friends, sometimes competitors, but just trying to build something that we thought would be great and get whoever could help us to help us do so.
I would also say that, like, open source is really one of the only means to actually influence technology, generally speaking, right? And I think pretty much every engineer has this kind of instinct to try to push their own ideas on everybody else, because you're doing it, you're building it the right way, right? And so I feel like there's a kind of strong foundation just in the basic personality of people who tend to work in places like that to actually pursue open source. So, for example, the last project that I worked on at Twitter, it was not going to be open source, but we always had it in mind. And, we were careful to make sure that the right interfaces were in the right places so that it could be cleaved off and things like that. And it actually enhanced the quality of the code as well, right? But I feel like, yes, it's ultimately driven by engineers, but actually good engineering in itself is an enabler of open source as well.
Yeah, I just wanted to follow. I feel like a lot of us as engineers, we're like scientists, and like we do, like a lot of the work we do are like science experiments, and we want to like share those with the world. And to me, open source is like this ongoing science experiment of engineering. It's like how you influence and how you actually can contribute new things back. And some of us have a lot of science experiments and are constantly going to the next project and the next project. But some people stick for the same science experiment for a really long time.
Just wanted to say, I think Marius' point was a really good one, which is that it feels, open source is a really effective way of changing the world. Okay, maybe like the world of engineers, and it feels really good to do that. Like, one of the things that I feel very good about at Buoyant, even if even if Buoyant, instead of our current rocket ship ascension and like sinks under the water, I'm still going to feel very good about the contributions that we've made, because we've actually we've had an opportunity to really affect people's lives, like not in like a super sappy way and like making their job easier or whatever, but that's still like, that feels really I think that feels really empowering, and it's one of the things that can really motivate you getting out of bed in the morning, like, and going to do your crappy job. Is you're like, okay, this is actually going to make a difference to someone out there. And for us, like, the Linkerd being open source, I think, was a huge avenue to that, to that actually being possible.
So raise your hand if you've committed to an open source project. That's pretty good.
Thanks, guys. So I want to shift gears for a moment, and we have a guest of honor here with us. From last year, like I really was wondering if founders of Twitter are aware of all this treasure trove of technology which exists here and drives a lot of projects which went into the world. And so when I've seen that Bistone is coming back to Twitter, I've seen a Medium post about this, and I think for my interpretation of the mandate was to bring the world to Twitter and Twitter to the world. And so that actually culturally is what we were trying to do with Scala by the Bay, right? Because essentially Twitter produced all this tremendous software, but it's not actively popularizing it outside because it's not the business model. So I thought, okay, like if Twitter is not coming to the world, we'll just bring the world into Twitter and inject it right here, right? And so, if there is some new stuff to learn about Finagle and other technologies, we'll basically, bring people in and mix them and match with the Twitter community. And I think we have more and more Twitter folks attending this conference, right? We have it kind of more business days, so more people can attend. But I'm really curious, right, about historical evolution of kind of technology at Twitter, and if the company as a whole knows what kind of value it has here and what it plans to do going forward. So I'd like to welcome Bistone to address Scale by the Bay. Welcome, Biz.
Thank you. I think I'm supposed to make a few remarks, and then we're all going to drink some beer. It's good to see a familiar face. Actually, just to give you a little fun fact, Jack and I in early 2008, and I think you might have been there, Evan, we very seriously considered open sourcing Twitter itself. But Ev didn't want to do that. Anyway, is this being recorded? Anyway, I just wanted to say I'm Biz Stone, and I work here with the wonderful Remy D, who is our open source program manager. And I don't usually share this because it's sort of sickeningly, hallucinogenically optimistic. But you guys are like that too. So I'll share this. I have a vision for humanity in 1,000 years, and it kind of, in a nutshell, it comes down to global collaboration. So just imagine the achievements we could make if we stopped dropping bombs and started dropping knowledge, and that if sharing our breakthroughs was just the norm, I think we would do in 1 year what it normally takes 100 years to do. And in the process of this grand collaboration, I think we would also just simultaneously, almost even as a side effect, solve the world's biggest problems. And that's what open source is, like a peek into that. Like, it gives us a peek into a non-dystopian future, where we're all actually working together and we're building off each other's work. And to me, open source has always been about, helping other people make progress. And that's that's kind of what Twitter's about too. That's what we've always believed Twitter was about, and that's what we think. And that's why we think open source is so incredibly important. You know, it's about giving back. It's about helping people make progress, and that's what we tried to do, or we try to do with Twitter. And we said that from the beginning when we formed the company. I gave a presentation. I said, if we're going to have a company, this is how we're going to do it. We're going to try to give back to the community, to the world. And we're going to try to be successful as a company too. And it's sort of this, the open source ethos just meshes really well with the Twitter culture ethos. So anyway, I also wanted to say welcome to Twitter, and I'm very proud that we've been able to host the Scale by the Bay conference for 2 years running now. I hope maybe it can become a regular thing. That would be really great, and with a lot more participation from Twitter. So that's really all I have to say. I just wanted to thank everybody for coming and for being here and for letting me say some stuff, and for Remy for inviting me. And yeah, we can, if you want to do questions, you can. I don't know that much tech stuff, but what we're doing right now. But I'm fully supportive, and there's also beer out there and beer and cheese. So thank you, everybody. I really appreciate it. Go Scale by the Bay. Love it.
Thank you, Biz. So I think